September 5th, 2019, Math 1. Words into equations, Part 1. Aiden Fisher, what is the learning goal?
It is I can use one variable equations and inequalities to model and solve the problems.
Excellent. And Taryn, why?
Math has its own language and rules. By solving equations, I learned the language of math and how it works.
These questions are rhetorical, which means you don't have to respond to them. But have you ever looked at a store receipt or bought something online? Do you realize that there are a bunch of equations that are making both of those things work? Computer programmers have created equations that calculate the sales tax, shipping, discounts, etc. It's a bunch of math that's running the world. Today we're going to look at a basic level, how to look at a real life situation and convert it into an equation and then solve that equation. It's almost everything we're going to see right now, you could do without an equation. You could just solve it by manipulating the numbers. But the goal is to create an equation and then solve it. It's about the creation process more than just getting an answer. So here's our first one. Actually, this is our kind of format for today. So the ending value is going to equal a multiplier times the variable plus a starting value. This is the general form that we're going to be working with today. When it comes to variables, choose smart variables. If I'm dealing with dollars, I'm going to use dollar for the variable or D for the variable. If I'm dealing with apples, I'd use A for the variable or even use the word apples as a variable. So be smart with the variables. Here we go. And create that variable early on. Figure out, hey, what am I even trying to solve for? What do I want? Read this question to yourself and don't write anything down. Just read it. Raising a hand. What is the question? Nico.
How many students were in each bus?
Okay, so students in each bus. Cool. I need a variable that's going to represent that. Not X, not Y, something reasonable. Gordon.
S.
S? And what does S represent? It doesn't. Chris, what does S represent?
The number of students on each of the buses.
It's number of students per bus. It's not students, because our equations aren't going to be able to handle students. An equation handles numbers. It can't handle a student. I can't take you and put you into that equation. That would be weird. So number of students per bus. So this is what we're looking for. So right here, we can already start making this thing up. So variable, what variable are we about to use?
S.
Okay. So I still have an ending value, a multiplier, and a starting value. Anybody want to match up something with something? Jordan.
331 students for the starting value.
So I started with 331 students.
Wait.
Gordon, where would you put that?
The ending value.
Okay, let's put that as an ending value. We're kind of ending up with 331 students. At the end, we've got them all on buses or in cars. So I'm left with a multiplier and a starting value. Okay, Jackson?
The multiplier would be 6.
6. So 6 right here. So 6 times the number of students that are on a bus. So what if there are 10 kids on a bus? How many kids are going on buses?
660.
What if there are 20?
100.
120.
Yeah, that's right.
Okay, cool. And we need a starting value. And everything's just coming out of the off of the board. A starting value. There's only one number left. JJ?
7.
7. This equation models it. I've got 7 kids in cars. I've got a bunch of kids on buses. I don't know how many kids are on buses. That's my unknown. But I know I've got 6 buses going. So 6 times, is it 10? Are there 10 kids on a bus? 6 times 10 plus 67. Did it work? Solve it. How many kids are on those buses? Got all those kids on buses. 7 kids in cars. Share it with Lauren. Say hello, Lauren. No, say hello, Lauren. How are you doing, Lauren? So that's the thing. Yeah, there's an easier way, but it's not about getting the answer as much as can you model this with the equation? Because I can't program do a little magical method. I can write programs based off of this kind of stuff. Do you see the difference there? So it's can we create the equation? That's what we're working on. Yeah, I can get the answer, man. 331 kids, okay. I'm gonna subtract out the 7, and then I'm gonna divide it by the 6, and I've got my answer. That's not what this is about. Can you model it with an equation? Okay, Maddie, what'd you get?
54.
What did you get, Chris?
54.
Did you share answers?
Yeah.
Good. Okay, 54? Does that work? 6 times 54 plus 7, does that really equal to 331? Yeah. Let's do another one. And we'll see if we can model it. Read it to yourself. And start thinking about the variable, the unknown. Presley, you get to choose the variable.
M.
M. What is M going to represent?
The money.
The money. What do you mean by the money? Money, 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 money. Money. I'm going to go to Taryn. What would you like to use for a variable? What do you mean by money?
How much each pencil costs?
Okay, so how much each pencil costs? So you guys want to go with M for money. Anybody want to choose a different variable? And what would you use?
C. For cost.
C, cost? Cost of?
Oh, each pencil.
Okay, what would you use?
Can you use like the dollar sign?
You could use the dollar symbol. What would you use, JJ?
I would use P for the number of pencils.
Am I trying to find the number of pencils? What would you use?
P for price per pencil.
P for price per pencil. I'm going to go with P. So P equals price per pencil, which is awesome because it's got 3 P's in it. I like it. Price per pencil. Okay. Let's start building the equation. So we're using P for a variable. I've got things like a multiplier, an ending value, and a starting value. Go for it, Nico.
Would the starting value be 24?
24? Okay, I can do it as a 24, sure. We'll do this 2 ways. Okay,
And for the,
ending value? Is that right? Got it?
7 pencils for the multiplier. It's not a number, it's written.
Yeah, it's written out as a word as opposed to the numeric sound. Is this working though? So if I buy 1 pencil, I end up with, what's that, like $31?
Switch to 7 and 10, right?
So that, well, 7 is saying I'm buying 7 pencils. 7 pencils times the price of a pencil plus $24, and I want to end up with $10.
Switch the 10 to the 24.
Switch the, if I switch the 10 and the 24, that's saying I'm buying 20. This is saying how many pencils I'm buying, right? I'm buying 7 pencils. If I switch those numbers, then it's saying I'm buying 24 pencils. Am I buying 24 pencils?
I'll switch the 10.
Switch the 10 and the 24. Okay. I didn't switch it. What do you think of that?
Yeah, okay.
This would work. This models it. So if I buy 1 pencil, no, excuse me, I'm buying 7 pencils. If a pencil is $1, I'd spend $7 a pencil, I'd have $10 left, that's $17, that didn't work, but if it, solve that. Find out how much does a pencil cost. P is the cost of a pencil. So it's like a pitcher, like a catcher. I'm throwing you the signs. What do you think? You waving me off, or we good with this one? We're gonna throw that one, okay?
Oh, I thought you were like saying no or something.
No, I'm saying what do you like? Anybody play baseball? It might. I don't know. So the third base coach, do they throw signs at the runner on first?
Yeah.
I watched Mark Roper, who does a YouTube thing.
Oh, yeah.
And he came up with,
Good.
he did an app that
Yeah.
can decode the signs. Yeah, it's pretty cool, man. I guess like,
Everyone has to put signs.
yeah, see, I don't know any of these signs. So this is my sign. You know what this one means? 2. This one, 3. It's pretty cool. So it's 2. Now, there is another way to model this. I'm going to model another way. I like this model the best, but I could do it with the 10. 10 equals negative 7p plus 24. Solve that. You're going to notice that solves the same way. This is saying every time I buy it, if the pencils are $1, I would take $24 and subtract out my $7, and I'm not left with 10. If pencils are $2, that'd be $14 being taken away from my 24 and leaving me with 10. After you're done with that in your notes, get out. What are your notes? Those are your notes? Are those even legible?
Probably not.
Oh, not. Get out your whiteboard and a marker, and keep out a calculator.
Can you get me a whiteboard
We're going to a carnival.
Oh, fun.
Well, it is fun, Jordan.
Yeah.
Jordan. More fun than tying your backpack together.
We all tied together, and then Logan Elliott decided he was going to run. And so everyone had to follow him because he was
Attached.
running for all of
He was
us.
attached in the center of us.
So we all had to run. Huh?
First thing I want, nothing on your whiteboard except for the variable. I want you to choose the variable and show me what you want to use.
Oh, for what? About that.
Give me a variable.
Oh my god, that sound.
Wait, is that right or wrong?
I don't know. We're just deciding together.
Oh, I will give you a variable. We're both.
And don't erase it, just write down a variable, don't erase it.
Great.
All right, Greenlee, what's your variable?
G.
And what does that represent?
The greatest number of carnival rides.
Okay, and Gavin, what's yours?
R.
What's that represent? I can't put a ride into an equation.
Greatest number of carnivals.
What do you got? What does C represent?
Carnival ride?
I can't put carnival rides into an equation. What's G?
G is the greatest number of carnival rides scale.
Okay, we're gonna use R for number of rides.
G sounds better. Are you doing this one in your notebook?
Nope. Build me an equation that represents this. I know it sounds like an inequality, just build me an equation. That's on your whiteboard. Build me an equation, we're using R for number of rides. It's good, man. Hold on to that.
What?
Good, hold on to that. Good, hold on to that. Perfect. Plus one.
Oh, that's fine.
I know that's what you meant. I know, that looks good like that. I gotta come over here so I can see these things. Good, good, good. Good, good. Ah. So actually, I'll switch those two numbers. So 25.
My friend passed out.
$4 to get in, plus this represents the cost of the rides you're about to go on. Equals
Okay,
125.
I was just confused because it says he has $25 to spend, so I thought that would be the start.
You could model it with a subtraction if you wanted to. I'm going to model it with this. $25 equals $1.50 times the number of rides. So this is going to be the amount he's about to spend on the rides. Plus the $4 he spent just to get in. $4 just to get in, the cost of all the rides, and that has to be $25, actually less than $25, right? Solve it. And tell me, how many rides can he go on? What's the maximum he can go on? That seems more reasonable. Yes, yes. 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 Yes, yes. Yes. No. Good. So how many rides could he go on? 14 rides.
14 or less.
No, or less. Well, but the question is, what is the greatest number of rides? 14? Nico, you could model it another way with the 4. Man, I don't like it though. I guess you could model it like that. I don't like that. So $25, here's subtracting out each ride he goes on, and he still has to have enough $4 to get in or something. It's not as clean. Let's do the next one. Decide on a variable for me.
Oh, okay.
Got it, okay. Give me a variable. Show it on the whiteboard.
Oh.
Hold on to that, hold on to it. Don't erase it yet. Hold on to it. Everyone shows me a variable, good. Got it? Don't erase it yet. Micah, did you choose a variable? Good, good. Green me a variable for this one? I'm going to put the book away. I'll try to keep you entertained. I try. F, and what does F represent, Bradley?
Amount of friends.
Number of friends. All right, build it.
You can't put friends in an equation.
But you can put your friends in, number of friends in. Solve it. And solve it then.
Okay.
And solve it. Okay, hold on to it. Just don't erase it.
She had 40
Yeah, good. Don't erase it though.
variables.
Now solve it. Give me the equation and solve it. And solve it. And solve it. Show me yours. You guys have 2 different equations with the same solution. Sort it out. Now, notice that doesn't follow our model either. It doesn't follow that model. Solve it.
Look.
Hold on to it. Solve it.
Oh my god, I put
Hold
40
on to it.
the
Hold on to
side.
it. Hold on to it. Hold on to it.
I put 40 on the wrong side.
Hold on to it. You changed yours, didn't you?
I'm stupid.
Aha. Very good.
I'm 32, but like 32.
Oh.
Eh.
I like this. Right? 2 times the number of friends. So if she has 20 friends, she gives away 48 balls. So it's not that. If she has 10 friends, she gives away 28 balls. Doesn't work either. Solving it, 16 friends. 16 friends?
She should have 0 friends.
Why?
Because so she can keep all the bouncy balls for herself.
But that's not nice. That's not good.
Well,
Zero.
he won them fair and square.
Maybe her friends were bullies.
Yeah, maybe her friends are bullies.
Oh, maybe you're the bully. What if she only had 1 friend and she
Yeah.
lost the rest? Or 0. Somebody has 0 friends.
I got 0 for this occasion.
Number 14. Let's start with the variable. Hold on to that. Actually, I'm going to start right here and then I'll come across the room. I need the variable for this. Cool. Hang on to it. Yeah, you can use that variable. Good, good. Okay. Chris, what variable do you want to use? Okay, good. Micah, coming back to you. Good. Good.
I'm very confident.
Good. T. Let's use T. What does T represent, Aiden?
How many tickets do you need to sell to get
The number of tickets? Build an equation. And solve it. And solve it. I'm not going to check. Does it work? So go buy that many tickets and see if you make enough money. Solve it. Solve it. Just solve it. Don't even have me check it. Just solve it. Give the equation and then solve it. So you're saying if I sell 20 tickets, I'll make enough money. Is that what you're telling me?
$1,000 in interest or $1,000 in like $1,000?
Oh wait, they lose 100.
Yes.
You say if I sell 20 tickets, I'm gonna have enough money.
Yes.
Okay, hold on to that.
Oh wait. 20 times 15 is
20 times 15 is 300 plus 700 is 1,000.
You're saying if I sell
Okay.
67 tickets, I'll make enough money.
That's what I thought.
You're saying 20 tickets, I'll make enough money. You're saying 114 tickets, I'll make enough money. You're saying 20 tickets, I'll make enough money. You're saying 67 tickets, I'll make enough money.
God, I think you're thinking about it.
You're saying 114, I'll make enough money.
Yes.
Right, so far I have 67, 114, and 20.
Oh, it's at least.
Yeah? Okay, who's going to represent 20? JJ, come up, you're 20. Who's going to be my 114?
I'll be here 114.
114, come on up.
Can I be 67 then?
Did you have 67?
I did.
Get up there, 67.
I'm a little bit taller.
All right. Recognize you are modeling these situations using an equation, but it should still mathematically work and make sense with the problem. How much is a ticket, Jordan?
Oh wait, no. Sorry. $15.
How many did you sell?
67.
So how much money just came in based off of the sale of tickets for you?
I need a calculator.
Okay. Now, you got a whiteboard. 15 times whatever your number is. Trent, how many tickets did you sell?
114.
How much money just came in? Figure it out. Turn around and figure it out. Hey, JJ, how much is a ticket?
$15.
How many did you sell?
20.
How much money did you just bring?
300.
Write that number down.
Okay.
All right. JJ,
Yes.
you now have $300 in your hand.
Okay.
I need you to go pay for the banquet hall.
Guess so then I need. Okay.
How much is the banquet hall?
So, $700.
Okay, so how much money do you have right now?
$1,000 that I need to.
No, you have $300 right now.
Oh, okay.
He has $300. You need to go and pay me. Give me my money.
I need to give you 1,700. 700. Well, no, no, you're 700. Yeah, that's what you're talking.
Can you even pay for the hall?
No.
He's gonna do.
Sit down. You didn't sell enough tickets.
Hey,
Jordan,
Oh.
how much money do you have right now?
1,005. 1,005.
$1,005. Okay. Now you've got to pay me $700.
Oh, okay. Oh man, I ran out of money.
Gary, you can always buy it.
I'm 305.
And you didn't make enough money because you needed to make at least 1,000. Trent, how much money do you have right now?
$1,210.
Got it. Pay me my 700. How much money do you have?
1,010.
Did you make enough?
Yes.
So I would model it good, Dixie. I'd model it like this. I want to end up with 1,000. There it is. This is how much money came in from selling tickets. Right off the top, I have to take off 700 to pay the venue. Yes.
Wait, you said you had to follow that. The plus, the it's the addition not matter? Or
It does matter, but I have, so
you can change it?
you can change it. You can change it.
How we like?
Well, actually, if you go back to one of our slides, we saw negatives popping up early on, right here, right there, -7 times the cost. So there are different ways to model it, but this is a model that does work. Because when I solve it, I get that value that I'm looking for. All right, this one, let's use S for number of students. Model it and solve it. Good. And don't erase it. Model it and solve it.
There's 9 buses. Variable is false.
That's
Wait a second.
Good. 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 Actually, we model. So here's 152. I'm looking at those numbers. Four kids in cars. 9 buses times the number of kids in a bus equals 472. Next one, let's use D for the number of DVDs. D for the number of DVDs. And solve it. Okay, hold on to that. Hold on to it.
Oh, me?
Yeah, just wait.
This is really not
Solve it. Hold on to that. Hold on to that.
I know.
Hold on to that. Hold on to that. Hold on to that.
Got my answer.
Hold on to that. Hold on to it. Hold on to it. Hold on to that.
Minus 50. Okay, I got it.
I want you to go buy that many CDs.
Okay, I choose my work. I can represent this number.
Yeah, I've got 2 answers. I've got some 15s and I've got some 10s. Anybody want to represent the 10?
Can I represent? I want to represent the 15.
Okay, you're the 15, you're the 10.
10.
No.
I'm 15 because I can prove this.
Yes?
It's a fact.
All right, so
Hi there.
I'm going to just sit down
Okay.
and I'm going to let you prove that your answer works.
Okay.
Okay.
Can I grab my whiteboard really quick?
Sure.
There's one right there.
This one.
I know.
Maddie, hold off because you're going to have to use words also.
Okay. Because 250 is equal to 20 times D minus 50.
right now. Your math is flawless. I see what you're doing. Yep, and right there you're going to say that.
D is equal to 15 because.
Okay.
Because 15 times 20 is equal to 300 minus 50 is equal to 250.
I believe you. That everything you just did there looks beautiful and perfect. Okay, but I want you to go to the store right now.
Okay.
I want you to buy 15 CDs. How much money did you just spend?
I spent 300.
Right? You don't have that much money. Okay. Now I need Maddie. Walk me through it. You go. I don't want an equation.
Okay.
I want you to go to the store and buy CDs or
Okay.
DVDs. Okay.
So I have $250. The cost of each CD is 20, and if you do 20 divided by
Man, I want you to.
50,
You're gonna walk into the store and this is what you're gonna tell the person. No, you're not. Great.
No.
I walk into the store.
Okay.
Okay, what are you gonna pick up?
The CDs.
How many?
10.
Okay. And then you're gonna.
Well,
we'll do this
I
in-
would probably pick up. I would look through them and I would see which ones.
No,
that I
don't
like.
overthink this. She walks in, pick up 10 CDs.
Okay.
Just show me, pantomime it, mime it.
Okay. Okay.
How many do you have?
10.
Good, you walk up to the counter.
Okay.
Boom. The person rings you up. How much does that come to?
250.
No.
Oh. Wait.
It comes to $200, but she still wants $50.
Oh yeah.
Which makes sense now that I think about it.
So,
It makes it
take a seat. So, we got to be able to visualize. JJ, get up there. Go to the store. Okay. JJ walks in the store. He's in the store. What are you getting?
I'm getting 10 CDs.
He's got 10 CDs. He walks up to the counter, puts them down. The person says, "Hey, give me."
$200.
You give them.
200.
Yep. How much money do you still have left?
$50.
Did it work?
Yes.
It works.
I hate you wrong.
Sorry, man. It's gonna happen again.
I need to buy a CD.
Okay. This one. I'm not gonna look at your answers yet. You build an equation.
Very hard.
I see those answers. Just hold on to them. I think you're missing a plus somewhere. Recognize you guys have different equations and the same. Show me your equations again.
Some pies.
No, this is,
No, that. What did you? No, it's the same equation with different answers. No, it's different equations make the same answer. Something's weird.
No.
wait, here's plus SP plus 4.
Oh, the phone's ringing.
No,
What's going on, Brady? Brady, buddy.
No, it's not.
Just a second. Madison,
Yes.
at the end of the period,
Yes.
go to the office.
Okay.
She says K. I think that's short for okay. Okay, bye. Is that short for okay?
Yeah.
K?
Yeah, because like when you're like typing, like pressing OK.
Yeah, because that extra O is like, whoa, my thumb's on fire.
Yeah. Like if you just press K,
Yep.
it's super easy.
Okay, that's good. You know what I use? That little thumbs up.
That's what my dad knows.
So annoying. That's what dads do. Yep. Sometimes I just use the avocado. Have we talked about the avocado?
No.
Not during class, okay.
I'm sorry,
Okay, show me some answers.
I got the answers and erased it. I got 12. What did you get? I got
Dude, I don't. You know what? Let me just get some equations there.
I know.
Chris, read me your equation.
Mine is 60 equals P5.
I'm going to put it as 5p
Oh, I see where I messed up.
plus 20.
Oh.
Okay,
Never mind. I
Maddie,
understand where I messed up.
yours is 60 equals 5p plus 4.
Yeah, I see where I messed up.
And both of you had the same answer though,
Yeah.
which is weird.
It's because when I wrote it down, I wrote 4, but when I did it on my calculator, I put 20.
Got it.
How, wait, where? Oh. 5 times 4.
Yeah.
Boom.
P equals
This is.
I was right. What can I say?
Well, Miranda, what does this number mean? Gavin, what does this number mean? Or what does that number represent?
The number of pies they made.
It doesn't. What, Lizette, what does that number represent right there? More specifically, the number of pieces. Presley.
Number of pieces of pie.
More specifically. Maddie.
The number of pieces in 4 pies.
Okay. More specifically.
No, okay.
The number of pieces of the 4 pies that contributed.
More specifically.
Number of pies the club made?
No. More Jackson.
The number of pieces to sell.
More specifically.
The number of pieces from the cafeteria.
Oh, these are the 20 pieces from the cafeteria.
Mr. Smarty Pants.
Way to go, Fresh.
This one right here, what would this represent? Even though this equation is incorrect, what does this represent?
The number of pies.
This is the pies from the cafeteria, which I need to multiply by a 5 to turn into pieces. What does this 5 represent?
The
Pieces of.
The number of pieces of pie that you can get from your club.
Good. So here are the pies that we're about to bring. Here are the pies the cafeteria is giving us. Here are the pieces we're about to bring. If I bring 1 pie, 5 pieces, 2 pies, 10 pieces, 3 pies, 15 pieces. I need 60 pieces. I solve it, and that should work out to be 8. I need 8 pies. I bring 8 pies. The cafeteria gives me 5 pies. We have enough slices. We all eat pie.
I wish I had pie right now.
Micah, what flavor is the pie?
Ew. Sweet potato. Oh, sorry, not you. That's
No,
not
you-
my favorite.
So, a life skill is to just go, keep it in your head.
Okay.
Because I think about all the things that you like that I don't like.
Okay.
Right? Yeah, go positive. Hey, that's it. I'm done. Bradley, can we end it for today? Bradley says done. You gonna do the outro? Bradley, but we're done. I'll do it for you. Ready?
My name is Joe.
Hi, my name is Joe. I work in a button factory downtown.
I like to go.
Turn this lever. You know that thing?
Yeah.
Yeah. Well, yeah. Thank
Then
you.
you gotta say, make sure you're staying on it.
Dude, I'm so tired right now. I'm done. That's it for today.